Good morning, everyone. It's Kurt from Simcoe Plastics coming to you aboard my sailboat, Resonate, a perfect name for somebody who works in the plastics industry, and we're located at the Barrie Yacht Club in lovely Barrie, Ontario, Canada. Continuing the weekly videos talking about elements of the plastics industry and certainly recycling and how we can do our part to improve recycling and have positive impact on our environment. So what I'd like to talk about this week, it's something that maybe a lot of consumers don't know about and don't understand, and we'll cover it fairly quickly, and it won't be technically painful, I promise. And the topic is fillers in plastics. So what are fillers? Well, fillers can be things like talcum powder, calcium. They can be fiberglass, both short and long strand. They can be Kevlar, they can be carbon, and they can be other combinations, and sometimes, combinations of minerals and glasses and other types of things. But they're typically minerals, sometimes biomass, and we're going to talk a little bit about that. So what do fillers do? The purpose of a filler is really to alter the physical properties of the base resin that it's being compounded or added into. A pretty basic example would be a polypropylene, a homopolymer, so just polypropylene, which by itself is a very versatile resin, but has some limitations on strength, and we can add talcum powder, maybe 20–30%, and we can make it a much stronger material. We displace some of the resin with the filler, and we can end up with a product that's potentially less expensive depending on what else we add to it. So while it's being compounded and filler is being added, we can take that opportunity to add different stabilization additives or colors or whatever the end user application requires. But the main thing to remember is fillers displace resin, and they change the physical characteristics of the plastic that they're in. So how does that impact recycling, and specifically plastics and water? Well, water, if you've heard the term density or specific gravity, perhaps you make your own wine at home, you might be familiar with the term specific gravity. Water has a specific gravity of 1. Anything less than 1 will float. Anything greater than 1 will sink relative to the water and that specific gravity of 1. So many plastics, the type of stuff we find washing up on beaches, the water bottles, for example, that has a specific gravity of 0.89, 0.9. Main thing, it's less than 1, so it will float. When plastics are filled and they have a specific gravity greater than 1, what's going to happen? It's going to sink. So when it sinks, the chemicals that are compounded into the plastic, they're going to go down to the water, they're going to sit in the water for potentially hundreds of years, and they're going to break apart slowly, leaching the chemicals into the water for that long period of time. So what do? It's simple. Don't put things in the water. Please recycle them. Make sure they're disposed of correctly. Even product that you put in the trash, which goes to landfill, just as a reminder, it will break down in the landfill, and those same chemicals will leach out and eventually find their way to a water table. But it's far worse when it goes directly into the water. So another argument for recycling. Now, in terms of different types of filler, there are some interesting options out there. Not all minerals have to be, not all fillers have to be mined, which it's a single-use item at that point in time. We can add what we call biomass to plastics, and biomass can be, it is plant-based. I've worked with milled oat hulls, but I have here a couple of examples. This is a coffee tumbler, and make sure we get that on camera. And the material that you see, the lightness, that's flax, and the overall dark color of the plastic is caused by coffee grounds. So there are a couple of things that we might otherwise put in our, not recycling, our compost, but we can put them in plastics and displace petroleum-based resins in the process. And it looks really cool. It's something that's different. Another fun application, we'll try and get this on camera. Okay, there we go. Those are guitar picks, and they're filled with milled hemp. So that's just something that's sort of fun and cool, and I'm going to play along with these at some point in time. I play guitar, so we'll see what they sound like. But those are some applications of interesting fillers. They're not yet mainstream, but just something different. They still potentially can make plastic over that specific gravity of one, so don't throw them in the water. But it's just something a little bit different that I wanted to share with you. So I'll sign off for now. If you have questions about fillers, put them in the comments below. And remember, get out there and protect your playground. We'll talk soon. Bye-bye.